All right. For the benefit of the students who actually left for their triple science lesson, I will be repeating this question again. So let's see. I have 200 cm3 of ethane. It burns in 100 cm3 of oxygen to form carbon dioxide and water. I'm going to start by writing the chemical equation first. So that's C2H. Oh my god. Hey. C2H6 gas plus oxygen forms carbon dioxide plus water. Okay, so I'm going to balance the equation. I have 2 carbon here on my left, so I have to put 2 on my right, 6 hydrogen, so I'm going to put 3. And then if on my right side, I have altogether 7 oxygen, so 2 times 2, that's 4, plus 3 oxygen, that's 7. So to balance it out, I will have to write 7 over 2 as a fraction, right? So 7 over 2 times 2 makes 7. However, I'm not allowed to write fraction in a chemical equation, so I'm going to multiply everything by 2. So this will be 7, and then this will be 4, and this will be 6. So this is how I balance my chemical equation. Okay, so let's move on to the question. As you can tell that ethane and oxygen, they are both in the gaseous state, so it is not necessary for me to find mole first and then after that convert to volume. I mean, convert from volume to mole and then back to volume again. Instead, I can just compare mole ratio directly. So I'm just going to show you how I do this. So from the equation, okay, 2 mole of ethane, uh-oh, the bell, reacts with 7 mole of oxygen. Okay, so this is how I get 2 moles and then 7 moles. Alright, so this is the part where you get an option. You can either choose ethane to be the limiting or oxygen. So I would like to use ethane. So taking ethane as the limiting reactant. Okay, alright, I'm going to take this as limit. By comparing volume ratio, 200 cm cube of ethane reacts with 700 cm cube of oxygen. Okay, so how do I get it? 200 is given over here, and then comparing mole ratio, I will need 700 cm cube of oxygen, right? So 2 here, and this is 7, so therefore it's 700 cm cube of oxygen. So in my reaction, I need 700 cm cube of oxygen. But then how much do I have? I am given 1,000. So since 700 cm cube of oxygen is needed, hi, and 1000 cm cube of O2, oh, hold on, is present. It shows that C2, your ethane, is the limiting ayo, reactant, and oxygen is in excess. I Do you get it? I need 700, but I have 1000. So this shows that oxygen is in excess and C2H6 is limiting. Okay, so now that I know which is the limiting and reactant and which is the one, oops, which is the one that is in excess, I will be able to answer my question. So the question is, what is the volume of carbon dioxide present? I will be using the limiting reactant to compare. Okay, so we're going to compare volume ratio of C2H6 with carbon dioxide. So looking back, the ratio is 2:4. Oops. So the ratio is 2:4. And then I have 200 cm cube of ethane, right? So which means I will have 400 cm cube of carbon dioxide. So in this reaction, 400 cm cube of carbon dioxide is being produced. The next part, what is the volume of gas left at the end of the reaction? So carbon dioxide I've produced 400, right? And then in this reaction, 700 cm cube is needed. I have 1000, which means volume of oxygen left will be 1000 minus 700 equals to 300. Okay, so this is the oxygen that is not used in the reaction. It's the leftover oxygen. The question wants me to find the total volume of gas left. So I have 300, and also in this reaction I produce 400 cm cube of carbon dioxide. So in other words, at the end of the reaction, there are altogether 700 cm cube of gas. Okay, I hope you understand this, and if you still need help, please come and look for me. Thank you.